Something is stirring in the halls of NASA. A whisper has become a low rumble, a current of excitement that has electrified the scientific community and captivated the world. It's a feeling we've had before, a tantalizing hint that we might be on the verge of answering one of humanity's oldest and most profound questions. Are we alone? The agency has scheduled a press conference for tomorrow, an unusual move reserved only for discoveries of the highest order. They have been tight-lipped, their official statements crafted with the precision of a surgeon. But the subject is clear: Mars. The red planet, our celestial neighbor, has sent us a message, and the Perseverance rover was there to receive it. The anticipation is palpable, a collective holding of breath across the globe as we wait to learn if our dusty, rusty neighbor holds the secrets to life beyond Earth. This isn't just another scientific update. It's not a routine report on Martian weather patterns or geological formations. NASA doesn't roll out the full press corps for just anything. These grand-scale announcements are reserved for moments that have the potential to rewrite our textbooks and reshape our understanding of the universe and our place within it. Think of the discovery of gravitational waves, the first images of a black hole, or the confirmation of thousands of exoplanets. The very act of scheduling such an event signals that what has been found is not just data, but a potential revelation. The agency's careful and deliberate silence only adds to the suspense, a calculated pause before pulling back a curtain on a new reality. The implications of what might be announced are staggering, rippling out far beyond the laboratories and observatories. To understand the weight of this moment, we must journey back to the mission of the machine at the heart of it all, the Perseverance rover. This six-wheeled, nuclear-powered mobile laboratory is the most sophisticated explorer we have ever sent to another world. Its prime directive is astrobiology. It was designed, built, launched with the explicit goal of seeking signs of ancient life on Mars. Its landing site was chosen with painstaking care after years of debate and analysis of data from orbiters high above. The rover didn't just land anywhere. It touched down in Jezero Crater, a location that scientists believe is one of the most promising places in the entire solar system to find the evidence it seeks. Why? Because billions of years ago, Jezero Crater wasn't the dry, dusty bowl we see today. Jezero Crater was once a place of water. It was a vast, tranquil lake, fed by a winding river that carved a path through the Martian highlands. That river, now a dry channel named Neretva Vallis, flowed into the lake and deposited sand, silt, clay in a magnificent fan-shaped delta. On Earth, river deltas are exceptional at preserving the building blocks of life. They are treasure troves of organic matter, trapping and burying the remains of organisms for eons. The logic is simple and compelling. If life ever existed on Mars, a place like the Jezero Delta is where we would expect to find its fossilized calling cards. Perseverance's mission is to be our robotic field geologist, reading the pages of this ancient stone storybook and searching for the chapter that tells of life. The rover's journey has been a methodical and patient exploration. It has crawled across the crater floor, its advanced cameras and sensors analyzing the chemical and mineralogical composition of the rocks. Each drill, each laser zap, each panoramic image has added another piece to the puzzle of Mars's past climate. The data has consistently pointed towards a once habitable environment, making the search for biosignatures all the more urgent. This careful step-by-step approach is what makes the current excitement so profound. The rover's trek up the delta and into the region of Neretva Vallis has been a journey back in time, and it seems that in this ancient riverbed, it has found something that compelled NASA's scientists to stop, take a closer look, and prepare to tell the world. The focus of all this intense speculation is a single rock sample meticulously drilled and collected by Perseverance in a region of Neretva Vallis nicknamed Sapphire Canyon. This isn't just any rock. It's a fine-grained sedimentary rock, likely a mudstone, which on Earth is a superb medium for preserving delicate fossils. Imagine the bottom of a calm, ancient lake. As fine particles of clay and silt settled slowly through the water column, they would have gently buried any organic material, like microbial mats or the remains of microscopic organisms, entombing them in a protective sarcophagus of sediment. Over billions of years, this mud turned to stone, creating a perfect time capsule. This is what makes the Sapphire Canyon sample, designated SC007, so incredibly special. What has the science team so intrigued is the sample's unique composition, revealed by the rover's onboard instruments. Sherlock Watson, a powerful duo designed to hunt for organic chemicals and textures, have returned data unlike anything seen before on the mission. The rock is unusually rich in carbonates, minerals that often form in the presence of water, and can be associated with biological processes. More importantly, it is interlaced with silica, a compound that is exceptionally good at preserving microfossils. On Earth, some of our oldest and most detailed fossils of early life are found in silica-rich rocks like chert. The combination of a fine-grained mudstone, rich carbonates, and veins of silica makes this rock a geological jackpot for astrobiology. The location itself is just as significant as the rock's composition. Sapphire Canyon is situated right at the margin of the ancient river channel, a place where the water would have been relatively shallow and full of nutrients washed down from the surrounding highlands. This would have been a prime location for life to thrive, perhaps in the form of photosynthetic microbes harnessing the faint light of the young sun. The rover's detailed imagery of the area shows finely laminated layers in the rock, thin sheets of sediment stacked one on top of the other. Such laminations can be formed by simple geology, but they can also be the telltale sign of microbial mats, vast colonies of microorganisms that build up layers as they grow, a classic biosignature we search for in Earth's oldest rocks. The secret held within SC007 is the reason for NASA's suspenseful silence and the world's rapt attention. To truly grasp the excitement, we need to understand what the scientists are looking for. They're searching for biosignatures. A biosignature is not necessarily a fossilized alien skeleton or a green, multi-limbed creature waving at the camera. It is any substance, object, or pattern whose origin specifically requires a biological agent. Think of them as the fingerprints life leaves behind on its environment. These can range from the very subtle to the more obvious. Chemical biosignatures, complex organic molecules unlikely from non-biological processes. Mineralogical biosignatures, certain carbonate formations tied to microbes. Textural biosignatures, layered stromatolites from microbial mats. The search for biosignatures is a game of probabilities. Nature can mimic life. Many geological and chemical processes produce similar signals. Scientists must rule out every non-biological explanation. The standard of proof is extremely high. For example, finding simple organic molecules like methane on Mars is exciting, as life produces methane. But geology can make methane too. Interactions of water and rock. What would be a slam-dunk biosignature? A complex organic molecule only produced by life on Earth, like cholesterol. Certain amino acids with a specific handedness. Another powerful clue is isotopic ratios. Living organisms on Earth preferentially use lighter isotopes like carbon-12. If we found a carbon deposit heavily enriched in carbon-12 compared to its surroundings, that would strongly suggest biological activity. It's like finding clear footprints in the sand. Wind can make ripples, but it can't make a perfect set of five-toed tracks. This is precisely why the Sapphire Canyon sample is causing such a stir. The preliminary data from Perseverance's instruments seem to point to a confluence of several potential biosignatures. Fine-grained, laminated mudstone, a potential textural biosignature. Carbonates and silica, mineral clues associated with life. And, according to the rumors, complex organic chemistry detected by Sherlock. One clue is interesting. Multiple independent clues clustered in the same rock force you to consider something revolutionary. Deepening the intrigue are the specific visual details Perseverance has captured from the rocks in Neretva Vallis. The rover's high-resolution cameras, which are capable of seeing features smaller than a grain of salt, have revealed some peculiar textures that have the science team buzzing. Within the layers of the Sapphire Canyon mudstone, the instruments have identified these tiny, dark, spherical concretions, each just a millimeter or two in diameter. Because of their appearance, the team has informally nicknamed them poppy seeds. These tiny spheres are clustered in specific layers of the rock, not distributed randomly, suggesting they formed under very specific conditions. While geological processes can create such concretions, their size, shape, and distribution are, in this case, highly unusual. Adding to the puzzle, another rock nearby exhibits a different but equally fascinating pattern. This one has been dubbed the leopard spot rock due to its mottled appearance, featuring dark, irregular patches embedded within a lighter-colored matrix. These spots are rich in manganese oxides, a chemical signature that, on Earth, is almost always linked to the action of microbes or the presence of high levels of oxygen in an atmosphere. Finding such concentrated manganese oxides on Mars is a profound discovery in its own right, as it points to a past environment that was far more chemically complex and potentially oxygen-rich than previously thought. The question that hangs in the air is, what process created these spots? These visual oddities, the poppy seeds, the leopard spots, are exactly the kind of potential biosignatures that get astrobiologists excited. They represent a departure from the ordinary geology we've come to expect on Mars. On Earth, similar structures are often the result of biological activity. For example, microbial colonies can act as nucleation points for minerals to precipitate out of water, forming spherical concretions like the poppy seeds. The key here is context. These features were not found in isolation. It is the combination of these strange textures with the promising geology and chemistry of the Sapphire Canyon sample that elevates this from a mere curiosity to a potential bombshell. This isn't the first time our hearts have raced with the possibility of finding life on a neighboring world. The history of planetary exploration is punctuated by moments of intense excitement and speculation, which provide crucial context for the current situation. In 2018, NASA's Curiosity rover, Perseverance's older cousin exploring Gale Crater, made a landmark discovery. It confirmed the presence of a variety of complex organic molecules in 3-billion-year-old mudstones. These are the carbon-based building blocks of life. Finding them was a huge step forward, proving that the raw materials for life were present on ancient Mars. However, these molecules could have been created by geological processes or delivered by meteorites, so the discovery, while monumental, was not proof of life itself. Another moment of collective breathholding came with the seasonal fluctuations of methane in the Martian atmosphere. Methane is a fragile molecule destroyed by sunlight, so its continued presence means something is actively replenishing it. On Earth, the vast majority of atmospheric methane is produced by living organisms, microbes, cows. The discovery that methane levels on Mars seem to rise in the summer, fall in the winter, was electrifying. Could this be the signature of subsurface microbes whose metabolic activity changes with the seasons? It's a tantalizing possibility. But again, geology offers an alternative. The jury is still out. And let's not forget Venus, Earth's other neighbor. In 2020, a team announced they had detected phosphine gas in the Venusian clouds. This was a stunner. On Earth, phosphine is almost exclusively associated with anaerobic life, microbes that live in oxygen-free environments. The clouds of Venus, while hellishly acidic, have temperatures and pressures in a specific altitude range that could, in theory, support microbial life. The announcement sparked a firestorm of debate. Subsequent studies have questioned the detection, but the episode highlighted our eagerness to find life in the most unexpected places, and the rigorous process of scientific verification that must follow any extraordinary claim. In the vacuum of official information, the global conversation has exploded. Social media has become a digital bonfire. Scientists, journalists, the public. The hashtag MarsLife is trending worldwide. On platforms like X, formerly Twitter, planetary scientists not on the mission are openly speculating, sharing charts of Martian geology and diagrams of potential biosignatures. They are, in essence, thinking out loud, trying to piece together the puzzle from the few clues that have trickled out. Their excitement is infectious because it comes from a place of deep knowledge. They understand the monumental effort behind this moment and the profound implications of what might be announced. The public reaction has been a beautiful mix of awe, humor, and heartfelt curiosity. Memes are already circulating, little green aliens peeking out from behind Martian rocks, or the Perseverance rover holding a sign that says, "I found something." This humor is a way of processing the sheer scale of what might be happening. It makes the incomprehensibly vast distance to Mars feel a little smaller. Beyond the jokes, there is a palpable sense of wonder. People are sharing stories of looking up at the night sky as children, of being inspired by science fiction, and of a deep-seated hope that we are part of a larger cosmic story. This isn't just a science headline, it's a deeply human event. Of course, with excitement comes a healthy dose of skepticism, and that is also playing out online. Seasoned science communicators are urging caution, and skeptics are reminding everyone of past, less conclusive announcements. They point to the high bar for proving extraterrestrial life, and the many ways nature can fool us. This is a crucial part of the scientific process playing out in public. It's a real-time lesson in critical thinking. The debate between hopeful optimists and the cautious skeptics creates a dynamic tension that makes the wait for the official announcement even more compelling. Everyone is engaged, everyone has a stake, and everyone is waiting for the evidence. The media is in a frenzy, with every major news outlet preparing for what could be one of the biggest stories of the century, all looking up at that little red dot in the sky and asking the same question. NASA understands the immense weight of the words, life on another world. The agency has a long-standing policy of extreme caution. You don't get to cry wolf, or in this case microbe, more than once. The scientific and reputational stakes are astronomically high. The very existence of a scheduled high-profile press conference is the most significant clue. NASA's media events are typically reserved for mission milestones, major engineering achievements, discoveries that have already passed a rigorous internal vetting process. To call the world's media together on a topic as sensitive as this suggests they have a very high degree of confidence. Consider the language they will use. Every word will have been scrutinized by dozens of scientists, communications experts, agency leaders. They will likely avoid definitive statements like, "We have discovered life." Instead, they may use more measured phrases such as, "We have found strong evidence consistent with ancient biological processes." "We have identified multiple, co-located biosignatures that are difficult to explain through geology alone." This careful phrasing is not meant to be evasive. It is the hallmark of good science. It acknowledges that the samples must still be returned to Earth for absolute confirmation in our most advanced labs, a process that could take another decade. The announcement will be the beginning of a new chapter, not the end of the book. The rarity of this event cannot be overstated. We can look back at the Viking missions in the 1970s as a cautionary tale. The Viking landers performed experiments on Martian soil that produced tantalizing, positive results for metabolic activity, yet other instruments found no organic molecules. The conflicting data led to a 40-year debate that is still not fully resolved. NASA learned a valuable lesson from that experience. Ambiguity can be as frustrating as a negative result. They will not want to repeat that history. For them to step onto a global stage, they must believe they have something far more robust than the Viking results. Something visual, something chemical, something contextual, all woven together into a compelling narrative. The suspense is therefore rooted in our trust in NASA's scientific rigor. We know they wouldn't do this lightly. We know the scientists on the Perseverance team are some of the most brilliant and skeptical people on the planet. Their own excitement, which has inevitably leaked out through unofficial channels, is what gives the rumors such credibility. They are on the front lines, staring at data that no human has ever seen before. As the clock ticks down to the press conference, we are not just